Okay, so we're talking about trigonometric functions, and we'd already talked about a little bit about the basic trigonometric functions, which are the sine, the cosine, and the tangent. And now we're going to be using these basic functions and some basic properties of the trigonometric functions to work on some problems. Now, the problems we're going to be working on use the concept of an identity. Now, what's the difference between an identity and an equation or an expression? An identity basically is gonna, or a trigonometric identity is basically gonna represent a mathematical expression using trigonometric functions. And the thing about this identity is that the identities can be represented in many ways, and these ways are equivalent. That's why they're called identity. And so we're going to be using some basic tools or building blocks here to work on these exercises. And I'm going to refer to these. I'm going to refer to these, and I'm going to write them down here. So we have them as a reference. And what are these basic, or rather fundamental relationships that have to do with trigonometric functions that we're going to be using? And take this kind of like a, you can take this or use this kind of like a formula sheet if you want. Kind of like a formula sheet if you want. But these expressions shouldn't be new to you guys. So the first basic expressions are sine, cosine, and tangent of x. And then there are some reciprocal expressions here. So we've got something called the cosecant, which is 1 divided by the sine of x. Then we've got the second, which is 1 divided by the cosine of x. And lastly, we've got the cotangent, which is 1 divided by the tangent. And also, we have a relationship between the tangent of x and sine and cosine.
So for the identity.
Yeah, these are going to be the basic. So let's say that we're going to be working on problems that have to do with identities. These are the basic building blocks or expressions that we're going to be using to work with. And I say basic because there are a lot of others that derive from these, but these are the basic building blocks. So it's sine, cosine, and tangent. Tangent is sine divided by cosine. Then we've got the reciprocals, cosecant, secant, and cotangent. And also, because of the reciprocal relationship, cotangent is going to be the cosine of x divided by the sine of x. And then we've got what are called the Pythagorean identities. And these represent relationships between the trigonometric functions that have to do with the Pythagorean theorem. So the first one, the basic one, is sine squared plus cosine squared is equal to 1. And that is derived from the unit circle that helps us to define the sine and the cosine. There's a couple of other Pythagorean identities that, that can be used. Another one is tangent squared of x plus 1 equals the second square of x. And cotangent square of x plus 1 equals the cosecant square of x. These are going to be the basic building blocks that we're going to be using to solve trigonometric identity. Yes, then.
The x is in degrees.
Oh, that's a good question. Right now, for these exercises, we're not going to be doing any calculations of values. Okay. So the x is a variable. Okay. It's important if we're going to be doing calculations to identify we're going to be working in degrees or in radians. Okay. Usually by default, you should assume that the variable is in radians.
So that one is 1 radian.
Oh, it's a unit of 1. It's a magnitude that doesn't have any units.
Oh, okay.
And so for now, that's why I'm writing x. We could have written theta. We could have written t. Right now, it's just a variable. And by the way, I'm going to be using x for all the exercises because in some of the exercises in the homework test, some of them have a t. And my t particularly looks like a plus, and I don't want to generate any confusion, so I'm always going to be using an x. So I'm going to take a screen grab of this, and I'm going to send it through the chat, so you guys can have that as a so you guys can have that as a reference for the exercises we're going to be doing. Okay. So now so you guys already have this, so keep those at hand. These are the ones we're going to be using at least for the first part of these exercises. I'm going to clear everything here. And let's go back to the homework test. So I'm going to be working on the even problems. So let's look at the first set of problems. So one thing that that I'd like to put forth about these problems, these are literally math push-ups. Okay, this is literally math workout. I always expect the question from a student that says when we can do these exercises, and says, what is this useful for? Actually, I'm going to be very frank with you. What we're going to be doing with these exercises is just practicing relationships with identities. Okay, and it's like doing exercise. Okay, you're working out your brain. I want to be very upfront from that, because as engineers, you're not going to be putting a consulting agency that says I solve identities. Okay, is that clear for you guys? You're not going to put a stand outside that says I solve mathematical identities for $5. Come here and I'll solve it, and you can use it for the party to get to impress somebody. But what we're going to be doing is practicing the identities. Okay, and the reason we're doing that is because you guys need to identify models. The other thing about these exercises that's a bit different from the others we've done These don't have an A, B, C, D procedure. These exercises that have to do with identities, have any of you had a situation of having a chain necklace, either yours or somebody else, and the chain necklace gets wrapped around and you need to untangle it?
Yes.
That's kind of how some of these exercises are. So what I'm trying to tell you is that you're gonna have to use some of your creativity. We're gonna have to use some of our creativity and visualization to see how we're gonna solve it, okay? And that sometimes is stressful for some people. So for this first set of problems, we're gonna be using the basic identities, and the basic identities are sine, cosine, and tangent. And it also says that use the even odd identities. Now, what does the even odd identities mean? I'm gonna switch over here to the PowerPoint, to the other PowerPoint of unit 2, I'm sorry. And just reference here that in the case of sine and cosine, we've mentioned this. The cosine function is even and the sine function is odd. And we'd already mentioned that because if we look at the graphs, the cosine function is going to be symmetrical regarding y, and the sine function is going to be symmetrical regarding the origin. So cosine is even, sine is odd. And if we talk about the rest of the trigonometric functions, tangent, cotangent, and cosecant are odd, and secant is even. Okay, so basically the even functions are the ones that have to do with cosine, because remember that secant is 1 divided by cosine. So cosine and secant are even, all the rest are odd. And that's what we're going to be using to address these problems. So let's look at the first set of problems here. I'm going to be jumping. So you already have this in Blackboard. What I'm going to ask you guys to do is this is going to be kind of like a workshop. So I'm going to be working on the even problems. So you already have these even problems there. I'm going to start working on them, but try to do them on in your notes as well. Maybe I'm doing number 2, but maybe you already did number 2 and you're starting already with number 4 and number 6, and so try doing them by yourself. I'm going to be switching between this one and the whiteboard, so please have the problem sheet at hand. So the first one we're going to do is we need to simplify these, and by simplifying them, it means ideally to leave them just as one trigonometric function. So let's do the first one that's actually very simple, that says tangent of alpha times cosine of alpha. And I'm going to switch over here to the whiteboard. And so problem number 2 says, and again, I'm going to be using x. So problem number 2 is tangent of x multiplied by cosine of x. What can we do there to simplify that one?
We use the one of tangent that is equal to sine over cosine. It's equal to.
Correct. So correct point. So tangent is sine divided by cosine. And this is multiplying cosine. And so what's going to happen with the cosine? It's going to get eliminated, and in the end, we're going to have the result is going to be sine of x. That's the most simplified we can have. Good. Now let's look at number 4. Number 4 says cosecant squared of x minus 1 divided by cotangent. Okay, what can we do with that?
You use the one where it's cosecant, for the cosecant 1 divided by the sine. And the other one is cosine divided by sine, I guess. No? Yes.
Okay, remember that this kind of like unraveling things, or there's, oh, by the way, there's more than one way to do the simplifications. So yeah, that's one path. And let's do that. Jorge?
Can we use the one that we said that cotangent to the square plus 1 is equals to secant? So
Yep.
we subtract the cotangent is equals to cosecant to the square minus 1. So we substitute and then we divide it, and at the end we are going to have the cotangent.
Let's do both of the paths. So let me go first with the simplified one, which is the one that Coyle is mentioning, and then let's go back to the one you mentioned, Marco. And we should get to the same thing. By the way, this is important. You can use different procedures to get to the same thing, and more than one procedure can be correct. The thing is how long and how laborious it's going to be. So what Coyle mentioned, we've got this is another tip. Whenever we have a trigonometric function elevated to the square or elevated to the power, let's see if we can use any of the Pythagorean identities. So there's one Pythagorean identity that says cotangent of x squared plus 1 is equal to cosecant squared. Right? So if I substitute this in the original expression, what I'm going to have is, let's first do this. We're going to have cotangent squared of x plus 1 minus 1 divided by cotangent of x. The ones are going to get eliminated, and the square is going to get eliminated with a cotangent. And in the end, this is going to be equal to cotangent of x. Okay, that would be correct. Now, that's one path. But Marco, you also identified another path that, by the way, is also a correct way of doing things. It might be a little bit more laborious, but it's also correct. Whenever we've got cosecants and cotangents and tangents, let's try to leave everything with regards to sine and cosine and see what happens. Okay. This is going to be a bit longer, but we should get to the same thing. So this would be path number 1. Now over here, let's see what happens if we take path number 2. Just to try another way of doing it. And path number 2, let's see if we can convert everything to sine and cosine. So the cosecant is going to be 1 divided by cosine squared of x minus 1. And here we're going to have cosine of x divided by sine of x. Okay.
Why, cosine?
Oh, no, it's sine, This is true. I would like to say that I did that on purpose to see if somebody would notice, but I would be lying, and it's being recorded, so thank you for that. It's sine. Sine squared of x. Let's try to join these two. And we're gonna have sine square root of x is equal to 1 minus sine square root of x. And here we've still got cosine of x divided by sine of x. Okay. So what we did here, we joined these two. The common denominator is sine square root of x. Sine squared of x divided by sine squared of x is 1. Sine squared of x divided by, multiplied by 1 is going to be sine squared of x. So we've got this. Oh, this here, we can also use Pythagorean identity, where we know that sine square root of x plus cosine square root of x equals 1. So this would mean that in the numerator, we would have 1 minus, or rather, let's do this.
It will be cosine.
Yes, this would be the same as having cosine square root of x is 1 minus sine square root of x. And so that would mean that in the numerator, we've got cosine square root of x divided by sine square root of x, and all of this is divided by cosine of x and sine of x. Here we do the, what I like to translate as the tortilla law.
Okay, yeah.
So I don't know how the tortilla law is called in English, but
When you can raise this,
It's foil, no? Isn't it called foil?
it's what?
Foil.
Foil? I don't know. I never heard the term in English. I call it the tortilla law. It's the like the tortilla. Cosine.
teacher, and it's not easier to raise this to the quotation.
Yes, but we're gonna in the end eliminate the. I'm just trying to do all the steps here. We're gonna eliminate the squares. And so what's gonna happen here is that the squares are gonna be eliminated. This one is eliminated with this one is eliminated with this one. And in the end, we're gonna have cosine divided by sine, and that's cotangent. Which is the same thing we had over here.
Oh,
Both procedures are completely correct.
in the Zoom session, the answer is not visible. It is?
The bottom?
Yeah, at the bottom of this question, the only thing is the arrow pointed.
Oh,
Part, a tiny part missing.
I can't,
But maybe it's your ratio.
I can't modify that.
It might be my resolution.
No, your ratio.
I'm gonna try to not
You can, on the
draw at the
option,
edge here.
on the option, it says zoom ratio. You can put the window 50% or 100%.
You can see it now?
Yes.
Okay, yeah, but I can't because I can modify it over here. So this is being recorded, but I'm also gonna add the procedures into the PowerPoint. So you guys have, so this is important, and I'm glad both Marco and Joel came up with different approaches. Both are correct. There's no penalization for doing the longer process than the shorter one, okay? Both are correct. So if you would do any of these, it would be correct.
But it's easier when we use the Pythagorean.
In some cases, yes. Again, these are kind of like unraveling the chain. Each problem is going to be a little bit different, so you have to visualize how you can approach it. But turning everything into sine and cosine and doing manipulations, that's always going to be a correct way to go, but it's going to be probably be a little bit more long.
The test I failed in second semester was of this. I couldn't solve. No. I really one.
It's it's like I mentioned, these problems have a certain need of visualization, and not all the problems are the same, and sometimes not that easy to visualize some of these solutions. Okay, so question with these before we jump to the next one. No, okay, over at home, how are we guys doing over there? Are you guys still with us?
Yes, sir, yes.
Go ahead, Marco.
We're not gonna have, the third unit exam is going to be the final exam, or we're gonna have one third unit exam, then the final exam?
No, it's just going to be the final.
And then the final, are we going to see what, the whole thing in the semester, or just third unit, or?
No, the final, remember that the final exam, the way the final exam is going to work is that the final exam is going to be everything.
It's like a semester.
Yes. And that actually should apply for most of the courses you need to check.
So there's no third period exam, but final exam.
They're just going to be the final exam. And in the final exam, remember that these are the alternatives. Depending on your grades, you can exempt the whole exam, or you may exempt just the part. You may have to do just the part that has to do with the new what we didn't cover in the previous exam, or you're going to have to do the whole exam. Those are the three alternatives, depending on.
It depends.
I'm going to tell you I expect to have that ready by Monday, the 29th.
It depends on the grades and your criteria, right?
Yeah, I usually look at the whole grades of the whole class, and depending on how that is, I take a certain level. So depending on how the group is doing, let's say everybody that has an average up to this point of 90, just to give an example, I'm not saying I'm going to do it, of 90, then they don't have to do it, the exam. If they have between this grade and this grade, they're just going to have to do the last part. And if they're below this grade, you're going to have to do the whole exam. And I'll expect to let you guys know that by Monday, the 29th or earlier.
But do you have an idea of what day will the final test be?
That's actually already in the syllabus. The exam is, if I'm not mistaken, the exam I think for you guys is on December 2nd, which is Thursday in class hours.
December 2nd.
Is the third and the final exam going to be on the same day?
Can you say that again?
The third and the final exam.
No, it's just gonna be the final exam.
Okay.
So we're not gonna have a third exam. It's just gonna be the final exam is gonna be the last.
Like, let's say, like the third, period evaluation, it would be the presentation.
You could say it that way. Yeah.
That's,
Are they moving something down there?
Since the first hour, there were some weird noises, so.
They're probably moving some.
do you know if Professor Mora does very hard, global exams?
I have no idea. Actually,
He said one part of the exam is going to be the lab.
¿Cómo que laboratorio?
Vamos a morir.
No se dice nada en laboratorio. Más que ver.
okay, so let's look at the next one. Let's have this be a happy place where you don't have to think about the other courses and whatever's gonna happen in the other courses, so remember to breathe. So one recommendation that I would give all of you is that, again, remember, and this should apply to all of the courses. There's a course syllabus, and the course syllabus are the percentages that are going to be used for the grading. Okay, and so something that you guys as students sometimes forget is that the grading is an integral grade that has to do with many things. So for this course, it's the exams, it's the homework tasks, and it's the presentations. So not everything resides on the exams.
Isn't you were the only teacher that actually explained their syllabus, how they were going to be grading?
Well, I think what happens is that we covered that at the beginning of the I'm sorry, of the semester. And at least I like to remember that throughout the semester. And so one thing that's important for you guys to remember is to look at that for all the courses. And the other is that be very mindful of the other things that are not exams. That's why in my courses, I always stress turn in the homework tasks. Even if you haven't completed the homework tasks completely or totally, you can still have part of that grade. So look at that and again, keep a hopeful outlook. Let's look at number 6. Number 6 says 1 plus tangent squared of minus theta.
Is that a Pythagorean?
Yes, but we can actually, there's a thing here that we can do. We can take advantage of the Pythagorean. It says 1 plus the tangent square of, again, I'm going to be using x's instead of thetas. Let's look at what's happening here. I'm going to break this one down in the following way. So then you notice it's Pythagorean, but in the Pythagorean one, we don't have the minus inside. Okay, so what do we do with the minus? Well, this is the same as having the following. 1 plus tangent of minus x squared. So the fact that I put the square here or indicate that the whole function is being squared is the same thing. Now, do you guys remember what we just mentioned about even and odd? Is tangent even or odd? It's odd. And just remember about the even and odd functions. Remember, the only even ones are cosine and secant. All the rest are odd. And so if tangent is odd, tangent of x is odd, that means that tangent of minus x is equal to minus tangent of x. And so this means that for the original function that I've got, then tangent of minus x is equal to minus tangent of x. But what happens if I have a minus something elevated to the square? The minus is going to get eliminated. So this is the same as having 1 plus tangent. And that's a Pythagorean. That's the Pythagorean relationship direct.
That is just to explain it, but if I was to say it's the Pythagorean, it's the same, right?
Yes, but you just have to get around the minus x because the Pythagorean doesn't indicate.
Yes.
Now, this could be a variation of the Pythagorean identity, saying that 1 plus tangent squared of x is equal to secant squared. But 1 plus tangent squared of minus x is also equal to secant of x. Oh, is that here? So imagine that I've got minus x elevated to the square. This is the same as having minus 1 times x elevated to the square. This is the same as having minus 1 elevated to the square and x elevated to the square. The minus 1 elevated to the square, this is going to turn into positive 1. 1 multiplied by x to the square, this is the same as x squared. So anything negative elevated to an even power is gonna turn positive. Okay, now let's look at number. Let's look at number 8. So 8 says cosine squared of x plus 1 divided by cosecant squared of x. So there's there's more than one approach that we can do here. I'm gonna use one approach. I'm going to turn the cosecant into sine. So cosecant is the same as having sine of x. And then I'm going to join these two. Oh, no. I made a mistake there. No. I'm mucking things up here. 1 divided by cosecant is equal to sine. Let's tangle things up. So 1 divided by cosecant is sine, 1 divided by cosecant squared is sine squared, and this is a Pythagorean identity that's equal to 1. It's about to.
Is not, cosecant is not 1 divided by sine. So if we substitute the cosecant, we're going to be like 1 divided by sine to the square.
Let's do it step by step.
And then we do the
So
dialogue.
well, here, so cosecant is 1 divided by sine squared. And then we can do the tortilla law. And this is the same as having cosine squared. So the sine is going to come up here. Okay. And so cosine squared plus sine squared, this is the Pythagorean.
Equals to 1.
And this would be equal to.
Yeah. Si no eres, no me hables. No eres.
La persona que me saludó, que no me puedo, que me
Iba contigo. ¿Qué le gustaste los mancitos?
una señora.
Era una señora. Era la mamá de ti.
¿Era tu mamá?
¿Es tu mamá?
Ah, sí. Me tripié, porque me estoy y digo, no, que buenas, viene un gran celular.
Buenas mañanas.
Y luego, bueno, no, pues es que me dijo, no, buenas noches.
¿Era tu mamá? Sí. El viernes. Y yo que voy a andar ese play con el baúl y me pegan. Y me toca eso.
Estaba en la página.
Ya déjales de tuyo.
Seguro se le parte el
Muy bien, ya que ya déjales de tuyo.
Acabamos de hacer estudio por lo que no
El judicial en varios casos, ¿no? El laúd, no. Se hizo un daño, ¿no? Ganas el rebote, pero la mitad.
Okay, so now we've got 1 plus 1, 1 plus cotangent of x and tangent of x. That's problem
Teacher,
10. Yes.
can I, for example, if I have one, can I use that factorial and just and substitute that one for sine squared x plus cosine squared x? Or that's not?
Yes. Oh, so if you have a 1 and you, yes, that's sometimes a trick that you can also do. Whenever we have a 1, we can substitute that for any of the Pythagorean relationships that we have, if that's useful. So yes. What I'm going to do here is I'm going to change everything to sine and cosine. So cotangent is cosine of x divided by sine of x, and tangent is sine of x divided by cosine of x. Let me do this with yellow here. Wow, you guys are really harmonizing there. That is at the same time very cool and very unsettled. But I'm gonna focus on the cool. So this is gonna be cosine squared and sine squared. That's gonna give us cosine squared divided by sine squared, and cosine divided by sine is cotangent. And 1 plus cotangent squared is cosecant. So- Yes.
I didn't know. I don't know why we didn't, I didn't have this answer, but I just substituted the thing to 1/1 divided by
Again, you said.
the chain. I substituted by 1 divided by 10, and then I use the zero and give me like.
It should give you the same, let's do that. That's another way of doing it. So let's say that this one is path 1. Let's do it the way what is mentioning. That's not necessarily, this would be another way of doing it. It might be even simpler actually. So I'm gonna call this path 2. And it's important because again, we could get to the same results with different paths. So this is going to be 1 plus, and so cotangent is 1 divided by tangent. We've got tangent here. So 1 here, and then we use the PLO. This was actually simpler. And this would be 1 plus 1 divided by tangent squared, right?
Yes.
And 1 divided by tangent is cotangent squared, and that would give us cosine. So yeah, we get to the same result. Yeah, that would be another way. It's correct. That's correct. So any way in which we're using the basic functions, as long as we're using them correctly.
Wait. Okay, the tan x over 1, the 1 is equal to the tortilla. Okay.
Just to explain that.
Como por favor.
Okay, there we go. Cameras in focus. Cameras in focus. Okay, so let's clear this. Okay, so so the next set of problems are asking us to now for the next set of problems, it says to reduce the expression to one single trigonometric function. So we've got an expression and we want to reduce it where we only have one trigonometric function. So we're still going to be applying the same basic identities we've been using up to this point. Consider the first one, which is number 12. And number 12 says cosine of x plus cosine of x tangent of x. Number 12. So we want to reduce that to have just one trigonometric function. What, any ideas how we could approach that? There's many paths, many ways to do it. Any ideas?
This is the same. Right. Or doing
Using the same tools and building blocks that we've used up to this point, what could we start doing now to simplify? Any ideas?
I don't know if it's gonna work, but can you make a tangent into a sine cosine?
We could do that, but there's more than one way to solve these. Let's look at that one. Let's call this one path 1. There's more than one way. Let's look at the many ways we could approach this. So let's call this one path number 1, where we are going to substitute. So we're going to say cosine of x plus cosine of x, and then we're going to turn this into sine squared of x divided by cosine squared of x. These are going to get eliminated with this one. We're going to end up with a cosine of x plus sine squared of x divided by cosine of x. Now, whenever we got a fraction and an expression, we're always going to try to join them. Okay. And so we're going to join these using cosine as the common denominator. So cosine divided by 1 is going to be cosine multiplied by cosine is going to be cosine squared of x plus sine squared of x. And we know that that's a 1. All of this is equal to 1.
So we second
Yes.
And so this is gonna be 1 divided by cosine of x. And this is gonna be equal to seconds. Okay. Good job. That's one approach.
Another question. Once you combine it, don't you actually erase? No, I'm asking you. On the cosines, do they not cancel out and just need one, or are you gonna keep the bottom denominator of cosine as well?
Oh, the purpose, when we've got a fraction, or when we've got two fractions, we want to join them, we always choose a common denominator. The common denominator is going to be the denominator that's a combination of all of the denominators that we have. So what denominator do we have here? We've got a cosine. What denominator do we have here? We have a 1. So we use the cosine as the common denominator. And the purpose is to join. Once we join them, we're not going to cancel them out because that would mean going back.
No, I mean when you. So. So because you have the cosine of the common denominator, why don't you just combine them and just cancel out one cosine, just sine square over cosine square?
Oh, because this one is squared, we can't eliminate it because it's the square. So in the common denominator, you've got a cosine here on the bottom, and you've got cosine squared. You can't eliminate these two. The only one that would be eliminated would be the one on the bottom. And again, if you join these two and then eliminate, you're going to get back to the same thing you had originally. Is that relatively clear? Now, this is one path. This is one way of doing it. It's correct. Let's look at maybe another way of doing it. Anybody have another idea of something we could do? Do we have something we could factor there? We've got a cosine here and a cosine here. What happens if I factor the cosine? If I factor the cosine, I'm going to get cosine multiplied by 1 plus tangent of x. And I know that 1 plus tangent of x is second squared. Cosine of x now multiplied by multiplied by second squared. Exactly. So here, I know that the second is 1 divided by cosine squared. What's going to happen there is that the square is going to cancel this one out, and we're going to get 1 divided by cosine, which is second. Now, I'm doing this in, again, more than one path just to show that we can combine, we can mix and match all of the trigonometric identities and get to the same result. And again, there's no penalization for using one procedure or another as long as we're using them correctly. We get to the right simplification.
So what this does is instead of getting like cosine of x plus cosine of x times squared, I just get the second of x and it will give me exactly the same number.
That's the concept of an identity. An identity means that I've got A, which A can be many things, and then I've got B that looks different from A, but they are equivalent. That's the concept of an identity. A mathematical identity, that's what it is. You've got two things that seem different, but mathematically they're equivalent. So yes, it's correct. You've got an expression where you've got two things adding up and you've got a factor over there. So you've got cosine plus cosine x tangent square of x. That is equivalent to secant of x. Okay? Even though they look different, they are equivalent. And that's the concept of an identity. Okay, questions with this one?